Welcome students to your favorite channel Pradeep Sir Classes as PSC, and again we are the numerical king series and AC Verma solution, and this is volume 2 and Gauss's law and chapter number 30, and the question number is 16. Why question number 16? Because it is a very important question, and so I discuss and explain it with a very conceptual form alone. Okay, so this is question number 1, and if you're first in that particular class, then go back to the previous one and you can follow the description box. Here the links are given. So all the electric field and force and field as well as the Gauss's law, all the numericals I completed, and very close to the second one, that is chapter number 30, and it is almost completed. That is after 15 there are 1 2 3 4 5 6 7 8 and 8. So there are only 8 questions are left, and I completed these also shortly. Okay, so let's start with question number 16. Write down the question first, student, and then try and then come back. So this is question number 16, and this is AC Verma. Okay. So students, the question is: a long cylindrical volume contains a uniformly distributed charge of density rho. Okay. So students, first of all, figure out the numericals. So this is a cylindrical volume. This is a cylindrical volume. This is a cylindrical volume, and a long cylindrical volume contains uniformly distributed charge of density rho. So the charge density is rho, and you have to take, this is the volume charge density. Rho is volume charge density. Volume charge density. Okay. So what is about volume charge density? The charge is distributed within the whole volume of the cylinder. Find the electric field at a point P. P is the observation point, and inside the cylinder volume at a distance x from the axis. Okay, so you have to calculate electric field at that particular point due to this distribution of charge, and it is a P point and it is x from that particular cylinder. Okay, so all the charges are distributed amongst inside the volume, and the charge is distributed throughout the volume. Okay, so first of all, students, take a Gaussian surface. Take a Gaussian surface or Gaussian cylindrical volume. Gaussian cylindrical volume, like that, a closed surface one. You have to take a closed surface, and this is the closed surface, and you have to take apply Gauss's theorem. So that Gauss's theorem is a phi net equal to E dot ds, and this is Q inside by epsilon naught, and you have to take a closed integration. So first of all, students, there are concept number, this is concept number 1. So this is concept number 1. So this is Gauss's theorem, that is phi net is equal to closed integration of electric field equal to 1 by epsilon naught Q inside. So net flux means when a charge is distributed, the charge can create field lines, and what are the number of field lines that crossing that particular surface, that is Gaussian surface. If we take a Gaussian surface around this one, there is a charge distribution, and it can create a field, and if we consider a Gaussian surface, then other particular surface, the field lines are crossing that particular surface perpendicularly. So the flux is generated due to this charge. Due to these charges, like that, it is a 3-dimensional concept. So charge electric flux are generated around that particular cylinder. So phi net equal to E dot ds equal to Q by epsilon naught. And first of all, students, you have to calculate the charge content within this volume, within this particular volume. So how we can calculate the charge content within this volume? The charge density is given, that is rho. So you have to calculate the volume of this cylinder. So it is pi r square. R square means you have to take x is the distance, so pi x square into, if we take this is h, then you can type pi x square h, and this is the volume. So the charge content within this particular volume, q inside, this is the q inside, equal to volume into density. Since volume into density, density equal to so total charge by total volume, this is called volume charge density. So charge equal to density into volume. So pi x square h is the volume of the imaginary surface, imaginary cylinder, the Gaussian cylinder, Gaussian surface. So this is q inside equal to this one. So flux E dot ds, if we integrate the electric field over this surface, then electric field into surface, this is 2 pi r h. So this is x h. Why it is the surface is 2 pi r h? Since the radius of this cylinder is x, then the curved surface area of this particular cylinder is 2 pi x h, and this is E equal to 2 pi x h. This is equal to q inside, means pi x square h. So this is pi x square h into rho by epsilon naught. Okay, so E into 2 pi x h, and this is equal to pi x square h rho by epsilon naught. So student, then you get electric field, and this is equal to pi and pi cancel. So E equal to x square h cancel this one. So x square rho by epsilon naught into 2x into 2x, then x and x also cancel this one. So rho x by 2 epsilon naught. So electric field is linearly dependent. So electric field is directly proportional to x. Electric field is directly proportional to x. So if we calculate electric field at that particular point, then the electric field increases up to that particular volume, and then the electric field decreases. Okay. So if we want to draw that particular electric field versus distance, then from that particular radius there is a linear relationship between the electric field, linearly directly proportional. So electric field increases from 0 to up to r. If this is r, then up to r electric field increases. Up to r electric field is proportional to x, and this is the maximum value, and then it is decreases. Okay. So this is you can draw an E versus x graph, E versus r graph distance. There is up to x, up to r. R means when it is, if you take this as capital R, then that up to capital R, it is increases linearly, since it is proportional to x, and then decreases. Okay. So you can draw this figure also, and so this is the concept that related with how we can calculate electric field due to a cylindrical distribution of charge. Okay students, and I think you realize that numericals, this is a very important numericals, and thank you. And last of all, I want to say, please subscribe this channel if you say that all the numericals given here are very conceptual, and wow, what a concept. Okay, so then subscribe and stay with me. Okay, thank you.